Hello students, how are you all? I hope you are doing absolutely fine. So welcome all of you at AriserTalent. In our today's lecture, we are going to discuss about some of the NCERT questions that are related to your chapter electricity. So let's begin with the questions here. So the first question in the sequence we have is, a piece of wire of resistance R is cut into 5 equal parts. So what is the question saying? We have a wire of resistance R and this resistance wire is cut into the 5 parts. This resistance is cut into the 5 parts. These parts are connected in parallel. If the equivalent resistance of this combination is R dash, then you have to find the ratio of R upon R dash. So what we have given? We have divided this resistance into the 5 parts. So the total resistance here will be R. So it means it will be R upon 5, R upon 5, R upon 5 and R upon 5. These are the 5 resistances we are getting here because the complete resistance is R. So I am dividing R upon 5 5 times here. Now these combinations are connected in parallel. So for the parallel combination, we have a formula that is 1 upon Rp will be equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3 plus 1 upon R4 plus 1 upon R5, because these are the 5 resistances we have. So on substituting this value, what I am getting? 1 upon R upon 5, 1 upon R upon 5, 1 upon R upon 5, and similarly we will get the same term 5 times. Now what we can do, we will shift this 5 in numerator. 5 upon R, 5 upon R, 5 upon R, 5 upon R, 5 upon R. These are the resistances we have. So I am getting here 25 upon R. What I am getting? 25 upon R. So we can write Rp as R upon 25. So this is the circuit for the parallel combination we are getting here. Now this Rp is our equivalent resistance, and for this equivalent resistance, in spite of using Rp, I have to use the term R dash, because it is given that equivalent resistance of the combination is R dash. Now what you have to find? You have to determine the value of R upon R dash. So if I am going to find out the value of R upon R dash, what it came out to be? It came out to be 1 upon 25. You can see here R upon R dash will give you a value that is 1 upon 25. So let's check the options here. 1 upon 25, 1 upon 5, 5 and 25. So which option is correct here? Option number A is the correct answer we have. That is 1 upon 25. So this is the solution for this question. Let's check me 1 minute. R upon R dash we have to find, but we have found R dash upon R. We have to determine R upon R dash. R upon R dash, and it came out to be 25 upon 1. So the answer is 25 upon 1 instead of 1 upon 25. So which is the correct option here? Here option D is correct. That is 25 upon 1 we have. So R upon R dash came out to be 25 upon 1. But if I am calculating R upon R dash, it came out to be 1 upon 25. So these two answers you have to keep in mind, because wrong answers or wrong options are always provided with the right answers. So this is the solution of this question. You can copy this from here. Now, moving to the next question in this sequence we have, which of the following term does not represent the electrical power? Now, for the electrical power, we know that we have a formula that is VI I can also write it as I square R. So these are the two formulas for the electrical power I have. So I have to determine that which formula is incorrect here, and for this formula we can also write it as V square by R. So these are the three formulas we have for power. So which formula is incorrect here? I square R, IR cube. This is not a formula for calculating the power we have. These three are the formulas we have for calculating power. So the correct option is option number B. Option number B is not representing the electrical power here. You have these three formulas for calculating the power. Now, let's move to the third question we have. An electrical bulb is rated 220 volt, 100 watt. So write the given specification conditions here. So you can solve the numerical as follows. Electrical bulb is rated 220 volt. So what is the voltage here? 220 volt. This is our case 1. And what is the power of the bulb? Power of the bulb is 100 watt. Now, when it is operated at 110 volt, what will be the power consumed by the bulb? So, in our case 2, what we have provided, we have to operate it at 110 volt. And what we have to calculate here? We have to calculate the power of the bulb. Now, firstly, when V and power is given here, you have to determine the resistance of the given circuit. So, from first condition, what I can write here, we have a formula for power that is equal to P equal to V square by R. We have a formula that is P equal to V square by R. If I am going to calculate the value of resistance from this formula, it came out to be R equal to V square by P. What is V here? 220. So, 220 square upon 100. On solving this, what I am getting here? 220 into 220 upon 100. 0 will be cancelled by 0, 0 will be cancelled by 0. And what is 22 into 22? It came out to be 484. This is the value of resistance here. Now, the same resistance will be for the same bulb in the case 2. Now, we have V equal to 110 volt and R equal to 484 ohm. And you have to calculate the power. So, for second case, what I can write here, I have to find out the value of P. P again is V square upon R. What is the value of V in the second case? V will have 110 square upon 484. Now, it is 110 into 110 divided by 484. So, it will be cancelled by 11. So, it came out to be 100 upon 4, and what is the value of 100 upon 4? It is 25. So, what is the value of the power in second case? The power in the second case came out to be 25 watt. So, let us check the options here. 100 watt, 75 watt, 50 watt or 25 watt. So, what is the correct answer here? It is 25 watt. So, what you have to do in this question, you have to determine the resistance of the electrical bulb. So, by using this formula, you can calculate the power consumed when the voltage is 110. So, there are three formulas for the power and you have to remember all the formulas because the numericals from the power is usually asked in your exam. Now, let's move to the next question in this sequence we have. conducting wires of the same material and equal length and equal diameter are connected in series, then connected in parallel, what will be the ratio of heat produced in both the combinations? So what you are provided with? You are provided with the two wires. Two wires. These two wires is having a same material, same length, same diameter. All conditions are same here. So same material, length and diameter. Now, first wire, in first case the wires are connected in series and the other case the wires are connected in parallel. So, in case 1 and in case 2, what it is given, there is a series combination. And in case 2, what we are provided with? We are provided with parallel combination. Now, if the potential difference is also same across the system, you have to calculate the heat produced in both the combination. Now, for calculating the heat produced in the system, again we will having a general formula, that is I square R or I square RT we can say. So, for calculating the heat in the circuit, we have a formula, that is I square R divided by T. One minute. This is the formula we have. So, for calculating the heat in the circuit, we have a formula, that is H equal to I square RT. From this formula, we can calculate the heat produced in the circuit. Now, you can see that two wires are connected in series having a same resistance. So, in case 1, total resistance Rs will be equal to R1. Same resistance we have, so we can write it as R plus R. So, it is R plus R and its value will be 2R. And what we have provided in case 2, we have given a parallel combination. So, I can write 1 upon Rp equal to the same resistance 1 plus 1 upon R, and it came out to be 2 upon R, and the value of Rp will be R upon 2. So, this is the value of resistance in both the cases. Now, I am calculating here the heat produced in series combination, that is Hs. It is equal to I square, value of R is 2R and T. This is our equation number 1. Now, we are calculating the heat produced in the parallel combination. Again I square, the resistance is R upon 2 and time is T. So, this is our second equation. Now, you have to calculate the ratio of heat produced in both the systems. So, what you will do here, if I want to calculate the ratio of heat produced, so I have to divide equation 1 by 2. So, what I am getting here, dividing equation 1 and 2. We will get Hs upon Hp equal to I square into 2R into T upon I square into R upon 2 into T. So, these are the equations we are getting here. I square cancelled by I square, R cancelled by R, T cancelled by T, and this 2 will be shifted in numerator. So, what I am getting here, Hs upon Hp equal to 2 into 2 upon 1, that is equal to 4 upon 1. So, what will be the ratio of heat produced in the system? The heat produced in the system will be Hs ratio Hp, and it came out to be 4:1. So, this is the amount of heat that is produced in the system. So, let us check the options here. 1:2, 2:1, 1:4 and 4:1. So, what is the correct option here? The correct option here is 4:1. So, again the same thing I am saying, that you have to learn the formulas for solving this type of the numerical problems related to power and heat produced in the system. So just copy this solution from here. So we will proceed to the next part we have. Now, the next question in this sequence we have is, this is our theoretical question. How is voltmeter connected in the circuit to measure the potential difference between 2 points? Now, अगर हमें पोटेंशियल डिफरेंस को मेजर करना है तो वोल्ट मीटर को हमें सर्किट में कैसे कनेक्ट करना होगा? तो वन थिंग यू हैव टू कीप इन योर माइंड दैट वोल्ट मीटर इज ऑलवेज कनेक्टेड इन पैरेलल इन द सर्किट. So, voltmeter is connected in the parallel in the circuit to measure the potential difference. So, we can write that voltmeter is connected in parallel to measure potential difference. It means if you have to calculate the potential difference, the voltmeter should be connected in parallel always. So this is your theory based question. Let's move to the next question in this sequence we have. Again there is a numerical problem. A copper wire has a diameter of 0.5 mm. So first write the given conditions in the question. So it becomes very easy to you to analyze the formula that will be used in solving a particular type of the problem we have. So firstly I am writing the given conditions here. Diameter is 0.5 mm. Now changing this millimeter into meter, what I am getting here, I will get here 0.5 into 10 raised to the power minus 3 meter. This is the first condition. Resistivity is 1.6 into 10 raised to the power minus 4 ohm. So the resistivity is this is our 1.6 into 10 raised to the power minus 8 ohm. This is 1.6 into 10 raised to the power minus 8 ohm. Now, what will be the length of this wire to make its resistance 10 ohm? So, what you have to determine? You have to determine the length of wire. And resistance given is 10 ohm. So now, this diameter, from this diameter, we can calculate the radius, and you know that that wire will be in circular shape. How you will know? You will know from the diameter that if I have to calculate the radius, the wire used in circular shape. So what will be the radius here? Radius here is 0.5 into 10 raised to the power minus 3 upon 2 meter. Now, the formula we have to apply, which formula you will use here? We will use the formula that is R equal to rho L by A. This is the formula for the dependence of resistance, factors for determining the resistance. Now, substituting all these values in the formulas, what is the value of resistivity there? 1.6 into 10 raised to the power minus 8. Then length of the wire we have to determine. Value of resistance is 10 ohm. And what will be the area? For the circular wire, we have an area equal to pi r square. So firstly, determine the area here, area equal to pi r square, pi equal to 3.14, and what will be the value of r? The value of r will be 0.5 into 10 raised to the power minus 3 upon 2. So, on solving this, what I am getting here? 2 1 are 2, 2 5s are 10 and 1.57. So, 1.57 when multiplied by 0.5, it came out to be 0.785 into 10 raised to the power minus 3 meter square. So this is the area we are getting here. So what is the value of area? 0.785 into 10 raised to the power minus 3. Now, we have to determine the length of the wire. So, the length of the wire came out to be, on shifting these values, 10 into 0.78 into 10 raised to the power minus 3 upon 1.6 into 10 raised to the power minus 8. And numerically on solving this value, what I am getting here, the length of the wire came out to be 122.72 meter. So it came out to be 122.72 meter. So you can see that how you will calculate the value of the length of the wires from using this formula. So firstly, you have to determine the area here. Area will be calculated by the formula pi r square, and substituting these values you will calculate the length of the wire. So this is the first half part of the question we have. So I am writing here case 1. Now let us move to the case 2. How much the resistance change if the diameter is doubled? Now what you have to do? You have to just double that diameter. If I am doubling this diameter, what will be the change in the resistance? You have to do this question in the second part. So firstly, copy this part from here so we can solve our next part we have. So copy this solution from here. Now, let us do the second part of the question we have. This will be our case 2. How much the resistance change if the diameter is double? This is our diameter and I am doubling this diameter. So 2 into 0.5 give you 1 mm, and 1 mm will be equal to 10 raised to the power minus 3 meter. Now, firstly determine the radius of the wire. Radius will be d upon 2. So it came out to be 10 raised to the power minus 3 upon 2 meter. Now, again we have to determine the area. Area will be pi r square, pi 3.14. Radius will be 10 raised to the power minus 3 upon 2. So what I am getting here, 2 1 are 2, 1.57. So it came out to be 1.57 into 10 raised to the power minus 3 meter square. So this is our area we are getting. Now, substitute all these values in the equation. R will be, what is the value of resistivity here? 1.6 into 10 raised to the power minus 8. Length of the wire, 1 to 2.72 we have determined in the earlier case. And what is the value of area here? 1.57 into 10 raised to the power minus 3. So on solving this entire step, we will get the value of resistance that came out to be 2.5 ohm. So what will be the value of resistance here? The value of resistance will be 2.5 ohm if you just double the diameter of the wire. So this is the case 2 we have. Just copy this case 2 from here. Now, let's move to the next problem in this sequence we have. This is our next problem. have to be provided with the value of current flowing in a given resistors with the value of the potential difference. So you can see that these are the values of current, these are the values of potential difference we have. Now you have to plot a graph between V and I, and you have to calculate the resistance of that resistor. So firstly, let us plot the curve here. So for plotting this curve, what I have to do, I have to draw the VI curve. VI curve means we have to taken the voltage values on the y-axis, and I am taking the value of current on this axis. Now, these values are so voltage must be taken on x-axis and current must be taken on y-axis. So here we have the voltage values, that is potential difference we have, and these are the values of current we have. Now, let us first label the values that are provided here. So, what will be the value of current? 0.5, 1, 2, 3 and 4. So, what I am labeling here, this is starting from 0, we have 0.5, 1.0, 2.0, 3.0 and we have 4.0. What are the value of potential difference we have? We have the value of potential difference as 1.6, 3.4, 6.7, 10.2 and 13.2. These are the value of potential difference we have. Now we know that the VI graph for any resistor came out to be straight line because it is going to follow the Ohm's law. So what I am getting here, I am getting the straight line here. This is the straight line curve we are getting here. Now, this slope of the graph will give you the value of the resistance. We have discussed in the Ohm's law that the slope of the graph will give you the value of resistance. And what will be the value of R according to the Ohm's law? R will be V upon I. This is how you will calculate the value of resistance from here. Now, just mark the values here. You can see that 4.0 value will correspond to 13.2. This is the value for 10.2. 2.0 will be value for 6.7. 1.0 correspond to 3.4 and 0.4 correspond to 1.6. So, we can draw the curve like this. This is the straight line curve. Now, this line will give you the slope of graph. And from that slope of graph, what you will determine? You can determine the value of resistance from this graph. Now, firstly, you have to determine the value of voltage here. So, the voltage can be determined as voltage V equal to 13.2 minus 1.6. It came out to be 11.6 volt. And the value of current, I is current here, it is 4 ampere here. So now you can calculate the slope of the graph from any of the value of the voltages and current you have provided here. So whatever the value you want to take, you can take any value from this system. So if this line is representing the slope of the graph, this is representing the slope of the graph, then what is the value corresponding to the voltage and current in this system? So we can see that the voltage is 13.2 here. Voltage is 13.2 here. You can see here that, and the current is 4 ampere here. Now, if I am taking the line of the graph up to this level, this is the slope of the graph, current is 2 ampere here, and what is the voltage here? Voltage is 6.7. So you can take any of the values here and calculate the resistance of the curve. So the resistance can be calculated by the formula V upon I, and if I am marking this line, this is our point O, this is our point O here, this is our point A, and this is our point B, and this is our point C. We will calculate the curve as slope of the A, slope of OA. So the slope of the OA will give you the value of resistance here. So the voltage here is 6.7 and the current here is 2.0. So 6.7 upon 2 will give you the value that is approximately equal to 3.35 ohm. It will give you the value that is equal to 3.35 ohm. So we can say that the value of resistance in resistor is 3.4 ohm approximately. So if you are taking the slope of the curve, you can find that the values are approximately 3.3, 3.4 on the entire part of the curve. So this is again a very important type of the questions that are usually based on the graphical representation. So here we have discussed about the NCERT questions that are belong to your chapter of physics, that is electricity. Now this lecture is over for today. We will deal with many more topics in our next lecture. Thank you so much and have a nice day.